The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
So for part B, we're going to be using this piecewise function to graph what we just did here a second ago. But what you want to do is you definitely want to use those limits to your advantage. So since at x approaches 3, from the positive side, we got an infinity response, or we got negative infinity, but we got some sort of infinity response. That tells you that we're going to have a vertical asymptote there. And it was, if you remember, as we approached 3 from the right, we got negative infinity. So that should immediately tell you that that went down towards that asymptote. Okay, let's see what else was going on. Well, between 0 and 3, this span right here, our y value is just 1. However, it's going to be open circles at both endpoints because we don't have or equal to signs. We don't have those final endpoints there. Okay. So as we this one is going to go like that. Keep in mind, you know this doesn't actually hit the x-axis over here because we can use our limit at infinity to test that. Our degree of the bottom is 1. Our degree of the top is 0. We don't have any x's. The degree of the bottom is bigger. That tells you a horizontal asymptote of 0. So we know this could not cross that line there. So finally, let's think about this first piece. We have the absolute value graph, which looks like the V shape. It's moved up 1. But we only have the left half of it because we only have the numbers less than 0. So that's just going to look like that. Again, we still have this open circle here because neither of those functions actually included 0 in their domain. So this is what our graph should look like. So the next thing we want to do is for part C, just figure out which values it was discontinuous, are they removable or non-removable, and how you can redefine a removable discontinuity. So let's think about all the discontinuities. We have a removable discontinuity here at x equals 0. So x equals 0, removable. We definitely have a non-removable discontinuity at 3. The function is discontinuous because it doesn't connect there. You can think of continuity as if the graph is connected or not. But it's not something we could just fill in to make it continuous. In this case, it's an infinite discontinuity because we have an asymptote down there. So x equals 3 is non-removable. So those are our two discontinuities. One is removable, one is not removable. So the last thing is, how could you fill in the removable discontinuity? Well, we would just need to fill in that hole that we made there. So usually when you answer these questions, you want to write them in function notation. What that means is if you wrote f of 0 equals 1, right? Filling in this point is x equals 0 means y equals 1. So f of 0 equals 1. If this was true, that would fix this removable discontinuity, and now your function would be continuous again. So how could you define f of x to make it continuous? If f of 0 was 1, then that would be continuous.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.